Perfect. A warm welcome to you to the breakout session, International Reuse Spotlights from Belgium and China. My name is Ursula Schließmann and I'm head of the business field Environmental and Climate Protection Technologies at the Fraunhofer IGB in Stuttgart. I'm very pleased to host this session. We have two very experienced speakers today who are presenting exciting realization projects in the field of water reuse. One example from Belgium with the special feature of coastal proximity, and the other in China, in Beijing, with various framework conditions. And before we start, I would like to point out that all have the opportunity to ask questions about the presentations in the chat. Now we can start with the first speaker. I like to present you Emmanuel van Houte. He's a hydrogeologist and he works for Aquaduin since 1992. His task was and is to develop sustainable groundwater management in the dunes. And infiltration was the preferred option. Pilot tests were done on wastewater effluent, performed from 1970 on, and it became operational, the infiltration project, in 2002. He participated in several European research projects, for example, Aquarec, Reclaim, Demoware, and now in Fresh for Seas. And I now look forward to your presentation, Mr. van Houte. Please start, yes?
Okay. So I will explain about our, you see my screen?
Yes.
Okay. I will tell you about our experience in Flanders, Belgium. So first to situate us, we're on the west coast of Belgium, Flanders, so near the French border. I will explain about the regions we have chosen for a combination of water use and MAR. We're situated near the coast, so there's presence of salt water north and south of the dune area. On this map, you see the dune area as the red lined one, and we have the sea north of us and the polder area south of us, where we, in both places, there's presence of salt water. We've seen a growing increase of drinking water demand since the 1950s. So this meant that in the 1980s, we were at the limit of the capacity of the dunes. And we had to look for an alternative because we had to keep the groundwater of the drinking water production in those dunes. The next thing was that there was a growing demand for ecological management of the dune area. Since the 1960s, with the Club of Rome, we also had to do something about this, but I see that a lot, yes. Why did we choose membranes? Of course, we go from wastewater to drinking water, so we have to take care of the customers and of the good quality of drinking water. We did thorough research about this quality issue. We did a HACCP study. We did the first tests with hormones at that time because we wanted to be sure that all these stuff are out of drinking water. And one of the main reasons also was because of the ecological management. We had to have a good quality of the infiltration water. We had to have a low salt content, like the natural quality of the dune water, and also a low nutrient content. So this is what we did. We closed loop in our site. We have consumption at the coast, and those communities, the drinking water from those communities go back to the sewer. The water is treated here, so we treat our the treated wastewater is then recycled by membranes and goes back to the dunes, and after consumption back to the wastewater treatment plant. So we are enabled to close circle in our region. The current scheme of the water reuse, it's based on the multiple barrier approach, and it's by ultrafiltration followed by reverse osmosis, and then the June water passage to manage aquifer recharge, of course. We have been introducing new things recently. We try to reuse the backwash of the wastewater as much as possible to increase the recovery of the whole plant. We will do that by next ultrafiltration next year. We also started investigating if direct reuse would be feasible in the near future. To to keep our multiple barrier, we do tests with activated carbon after the reverse osmosis. And next month, a new treatment, a natural treatment, will become operational, and we will use willows to treat the reverse osmosis concentrate. The conclusion of our water reuse scheme combined tomorrow is that about quality, we have increased the quality because the hardness is much lower now. The water keeps stable microbiologically, and we have had no issues so far with micropollutants. About the natural values, they have been enhanced. We have increased by the diversity by this combination. We have shown that in the last couple of years with increased drought cases that we are a good way to adapt to climate. We're more robust now because we constantly replenish the dune aquifer, and we have the project resulted in a secularization of the drinking water distribution in the neighborhood in the area. But we should focus that quality should always be the priority when you do reuse, and it should be risk based. Some final remarks. We have seen a lot of evolution in 20 years time when we started, or when we piloted. It was all about hormones. Now it's all about climate change. We've seen an increasing amount of compounds detected. The LOQs went down. But one important thing is that we have seen that with reverse osmosis, we have been able to remove almost all of them. We only found after RO so far. And then the current situation of the water use for drinking water in Europe is that in 2003, another scheme started in the UK where they use it to augment the river water, putting it back to a reservoir. There was an experiment started in Spain in El Porto la Selva in 2015, but this has been stopped, I heard. We have also launched the Water Reuse Europe Association in Europe. It was in 2016 as a result of the DemoWare project. And last year, a new treatment plant with reuse became operational in Sweden. So that's where we are now. And that's my presentation. I'm sorry for the technical problems.
Thank you very much.
I'm open for all questions, of course.
Thank you very much for your presentation. Now, feel free to ask by type them into the chat. And while we are waiting, I have some own questions, maybe. One will be, I understood that the trace substances are contained in the RO concentrate, and this concentrate or retentate stream is fed directly to the willows, right?
Yeah, it will be done next month, yeah.
And what happens to the trace substances there? Are they degraded, or are they after some time can be found in the groundwater?
Well, they will not go to the groundwater. It's an impermeable basin, so they will not go to the groundwater. We have been investigating this willow treatment for 5 years in a pilot scale, but then we didn't look at those trace elements. But now we will look, and I'm sure that we will have some result on removal of those pollutants, because there's a huge bacteriological activity, and there's a great content of organic material in this willow treatment. So I'm confident that it will do a lot, but that's what we will invest in the first years, of course.
Okay. Thank you. So there's another question. What is the typical OPEX per volume and hour, cubic meter and hour treated with this treatment train?
The investment we did in 2001, 2002 was 7 million euros. And that was for a production of 2.5 million cubic meters a year. We have an average production since the start of 2.2 million cubic meters per year. And the current cost after all these years, because we have amortized a lot of those investments, is around 40-45 euro cents to produce 1 cubic meter of infiltration water, which is good, because we have to pay 1 euro if you have to pay 1 cubic meter drinking water to the neighbors. So
okay,
it's competitive. Yeah.
Thank you very much. So if there are no more questions to this presentation, I will want to thank you once more. And we come to our second speaker. It's Professor Zifo Li. He's a professor at the University of Science and Technology, Beijing, since 2004, and he's head of the Department of Environmental Science and Engineering. And he's also director of National Environment and Energy International Cooperation Base. He obtained his PhD in environmental engineering at the Hamburg University of Technology in Germany in 2004. And he worked as scientific researcher at the Institute of Urban Water Management, University of Duisburg-Essen in Germany. And he's involved in many international projects. He's author of more than 200 research papers in peer-reviewed journals, books, contributions, and international conferences. The stage is yours, Professor Li.
Thank you very much, Mrs. Liesman. It's my, you can hear me?
Yes, we can hear you, and we can see your presentation.
Okay, that's great. Okay, it's a little bit slow. Yeah, thank you very much. And it's my great pleasure to be join this meeting. And before start to present this wastewater reuse, I want to have a very brief introduction to my university and the department with some beautiful pictures. You can see all these pictures from our campus. Our university is located in the north of Beijing. Maybe you can see here is a Tiananmen Square, and our university USTB is in abbreviation. It's about 15 kilometers far from Tiananmen Square. And our university also belongs to the top 30 normally in China. And according to the QS, this ranking list in the world, we are ranked in 2012 is 414. Our department is the Department of Environmental Science and Engineering, was founded in 1996, and we can offer accredited fields of study in bachelor's, master, and doctoral degree in Chinese and also English, also postdoctoral research fellow positions. And currently we have 53 faculty members, and among them 18 professors and also 20 associate professors. So this is just a short introduction, and I hope we can see you next time, not through this virtual meeting, and also welcome to our university. Now come to the presentation. Today I give a short introduction to the wastewater reuse in Beijing. As you see, actually water resource in Beijing is very limited. You can see in this part, it works now. This part, average renewable water resource in the world is 5,732, according to this statistic in 2017. And but in China, average is 2,029. And in Beijing, you can see only 180 cubic meter. So it's we can see Beijing is an extreme water shortage in mega cities. And that's the reason also the comprehensively promoting this construction of water saving society is urgently required. And actually also from this picture, you can see in Beijing, this distribution of different reuse, these water consumptions from agriculture, household, industrial, environmental use, and this is total this water consumption. From this, we can see the total water consumption is relatively stable in last 20 years, from 2000 to 2020, and a slight increased. And the most of this agriculture, household, and industry, you can see the agriculture decreased, and the household slight increase, and industrial also decreased. But the environment, this consumption increased because of the more greenery these areas. And from wastewater treatment, you can see in the last years, since 2000, the wastewater treatment capacity is over 1 million cubic meter per day, and then increased very fast in the last 20 years, from this 1 million to almost 7 million cubic meter per day. So this increased capacity also provide a condition for reclamation for the water, reclaimed water production. You can see these pictures from 2005 to 2019. The reclaimed water amount increased also from this 0.2 billion to 1.2 billion. So yearly, this reclaimed water amount. And roughly the daily reclaimed water production is about 4 million. This equals to 2 Kunming Lake. Kunming Lake is the summer palace. So it's a big lake. And here we can see in Beijing, there are so different scale wastewater treatment plants. It's 176. And among them, also 56 have this reclaimed water, this treatment system. And the total actual this capacity is 1.2 billion, almost 1.3 billion cubic meter yearly. So you can see this capacity is different. Here is a unit is 700,000 cubic meter per day. This capacity, you can see this is 6. Here is a Chinese unit. It's a little bit different. And in China also, relevant to this national standard about wastewater reuse have been released. You can see from 2002 and 2005, 2010. Yeah, so different kinds of this standard for the quality control. And to the case study, actually, I prepared three cases because of limited time. I want to present two cases. One is this development zone in Beijing. Another one is this dragon ship water system. You can see the first one is wastewater reuse in Yitong development zone. There is actually, you can see, located in the south of Beijing. It belongs to Daxing district. And here in 2020, the area of this development zone is about 212 square kilometer. And the area for construction is about 100 square kilometer. So here you can see also still a lot of green.
So as long as he wants to come back and he's trying, maybe we can start discussion. There's another question for the first presentation. Mr. Van Houte, is there any particular observation or feedback concerning the RO operations after such a long time of operation?
We have had very good results with our reverse osmosis so far. So we have an average lifetime of 6.5 years. We started our fourth set now beginning this year, end of last year. So it's going very well. We've also noticed it's easy to control because you can do it with conductivity. Of course, you need to do some other controls. What we do now is that we use, we've been seeing that benzotriazoles are not, are one of the compounds that goes through the membranes. So we are using this compound to control our RO. So you have to look for one indicator that's good to control. We haven't seen, we've seen only a small decrease of saltwater removal over the time. That's why we replace the membranes when we're too low, and this is for us it's 97.5%. Then we replace the membranes. But I must say that the last set of membranes that we have replaced have been reused in industry where they don't have to such, where they don't need such a high salt removal. So they have been working for over 1 or 2 years extra in industry. So yes, reverse osmosis is a good treatment that you can control very well, and if you take good care, they last for quite some time.
Mm-hmm. Thank you. I now hear that Professor Lee is now online again.
You can hear me?
Yeah, we can hear you.
Okay,
Maybe we can
great.
proceed with your presentation.
Okay, I can continue, or
Perfect.
if possible. Thank you. Sorry.
No problem.
Okay, I just let it like this one, not for the full screen. And just a moment. Yeah, for this one, this is also typical in this E-town. There are a lot of industries, factories, and mainly also for the electronic process enterprises. So there's reason for this reclamation. They use also this microfiltration and reverse osmosis for the advanced treatment. The wastewater from the treatment plants actually already treated by biological process. And after this, they flow into this reclamation plant and treat it. And you can see this is actual. Yesterday, I downloaded this online measurement values. You can see COD is less than 0.7, and TDS is total dissolved solids is 54 milligram per liter, and pH is 6.56. This is the wastewater for the electronic process enterprises. They supply for this. And the second case is dragon-shaped water. This is located direct behind this bird nest. So, Beijing Olympic, this national stadium. And for this, this is the general data. The reservoir, all this water system is actually a 0.75 million cubic meter, and the total water surface is 48 hectares. And the main water sources is reclaimed water from wastewater treatment plants. So these wastewater treatment plants use this MBR process, membrane bioreactor, this process for the treatment, and then come to this water system. But at the beginning, it has still problem because this is only the water source. So they have also green color with relative not very clear this transparency. That's the reason when this eco environment company was entrusted to do this advanced treatment in this water system. You can see this water system looks like a dragon. So the company divided this shape into the 9 sections. In this different section, they planted different submerged plants. You can see here, this is the pictures. So after this, also our team did this monitoring cooperated with this company in 2013 and 2014. And then we get some also data from here. You can see from W1, this first inflow come to the first section and to the ninth section, ninth part. You can see the TN reduced through this submerged plant, and also ammonium reduced. Total phosphorus, below 0.1 milligram per liter is relatively stable. And COD, also stay almost constant without this effective reduction by these submerged plants. But it looks very nice, very clean. You can see these pictures. So after this submerged plant treatment, this reclaimed water, so stay in this system. So here is some more picture about this. And but still some problems after our this analysis, the seasonal impact. So you can see in the spring, summer, and autumn is relatively stable. In the winter, these plants actually don't work properly. They have some the unstable problems, and the COD removal is relatively low, this efficiency. And also another problem, we planted these submerged plants, and each year we should harvest this, and the disposal also increases some this cost for this. And you can see also this fluctuation of this total nitrogen from this data. But generally, this system still since 2008 is always kept this relatively stable quality, and it's a good actually case for the reclaimed water reuse for this. And in China generally, the wastewater reuse is especially in the north for these water shortage regions is important these parts. But because of this climate change, as also von Hotte mentioned, that also the low carbon requirements, this carbon neutralization. So I think future this line system maybe will be changed into this source control this system. We want to not only recover water, also recover some resources. So this is the future. So that's a short introduction from my side. Thank you very much for your attention.
Thank you very much, Professor Lee. Now it's open for questions. There's the first question. What happens to the brine generated from the RO process?
This generated brine, this return head will back to this treatment plant.
Okay. It's other than another example was the treatment with the willows in Belgium. Have you or did you think about some kind of treatment by plants, by nature-based processes, as you did it for your mainstream? Also to use it also for the brine?
Actually, if we use this for the environment use, so like landscaping or this urban river water supply, we don't need this reverse osmosis for this treatment. Yes.
Okay. And there's another question. Is the low COD lower than 1 milligrams per liter in the E-town a demand for the industry?
Yes, it's an electronic process. They need this high quality. Yes, yes.
And then we have another question. You described that a large share of the wastewater in Beijing is reused. For which purposes in the reclaimed water? Is the reclaimed water used?
Yeah. In Beijing, actually, almost all the these divisions use this waste reclaimed water, so including industrial and landscaping. But I think the larger portion actually for the urban water, this urban river, this water supplement. Yeah. The compensation of this urban river, so these creeks or rivers, and also landscaping irrigation is this part. Mr. Slisman, you are muted.
I was muted.
Yeah,
there's another question. In the Dragon project, is there any reduction of the pharmaceuticals through the treatment with the different plants? So were you focused also on pharmaceuticals reduction? I think his online connection is not working anymore. So maybe there's another question to the first presenter. Yeah, he's not online anymore, Professor Lee. We have now some minutes left, and maybe Mr. Van Houte, I have another question. Your process, it seems to be that it's working. Maybe some some slight adaptation is necessary, but I think we have a lot of similar problems worldwide, and the question is it possible to adapt it to other regions very easily, or is there more effort from your
No,
side to
well,
go international?
water reuse is mainly used in countries where it's, or regions where it's warm and dry, like in California or Texas or the southern part of the states. Singapore is also a good example, Namibia. Of course, we have shown and others have shown that you can do it in a safe way, but we should, if it's drinking water, which is at stake, we should always use the best source. So we shouldn't look to reuse in the first place. If we have good groundwater, that will always be the best source to use, because then you don't have to use the same amount of treatment. We have to take into account that using membranes, and when you're reusing, most of the time you need membranes, consumes quite a lot of energy. We also try to minimize that to an extent, but it uses energy. So if we want to combat climate change with reuse, and we use even more energy, then we will add to the problem. So we should always, yeah, take care and consider the different aspects of a project. So we should always look for an integrated approach. Yes, water reuse can solve a lot of problems, but we shouldn't think to it in the first place. It will only be an option in the end. Another thing is that not all effluents will be available for water reuse, because much of the effluent are used for e-flows to keep a certain amount of water into rivers, into lakes. So it's not that we will be able to always reuse 100% of the produced effluent, I think. Is that a question to your answer?
Yeah, thank you. Thank you very much. Are there more questions? I now can see that Professor Lee is now online. He's back.
You can hear me?
Yes, we can hear you.
Okay,
And the
good.
last question was in the Dragon project, concerning the Dragon project. Is there any reduction of the pharmaceuticals through the treatment with the different plants?
We didn't measure this. This is a good suggestion. We will do this maybe next stage. Yeah, thank you very much. But actually, a lot of research about this effluent from wastewater treatment plant have been done.
Mm-hmm.
Yeah, yeah.
Thank you very much. So now unfortunately, we reached the end of our session. I think now we would be warm to discuss more and more, but maybe we can find another opportunity to discuss these topics. And I thank you for the presentations. I thank you, thank the audience for the questions. Yeah, thank you very much for participating, and see you next time. Have a good meeting and a good afternoon today.